All right, the last thing we're going to look at in sequences and series is an infinite geometric series. So we have the series from n equals 1 to infinity of a r to the n minus 1. So if we wrote out some terms, that'd be a, and then ar, and then ar squared, ar cubed, and etc. That's what our sequence is going to look like. The formula for the um, sum of that sequence is going to be the first term, or a, divided by 1 minus the common ratio, and that's if the absolute value of r is less than 1. So we can have a negative common ratio, and that'll be okay as long as it's less than 1. If the absolute value of the common ratio is greater than or equal to 1, then it's going to spiral out of control, and it's not going to be what we call convergent. So let's look at an example here. So let's say we have the geometric series 1 plus 1/4 plus 1/16 plus 1 over 64. So what we're multiplying by each time is 1 over 4. And that's our common ratio. And we can certainly see that 1/4 is going to be less than 1. And so what we can say is that this particular sum converges, or we have convergence, and then it converges to, well, the first term is 1, so 1 over 1 minus 1/4, so it's going to be 1 over 3/4, and we're just going to take the reciprocal, and that's going to be 4/3. Okay, let's look at another example. Let's say we have 1 plus 5/4 plus 25 over 16 plus 125 over 64. So this time we're multiplying the numerators by 5 and the denominators by 4, so our common ratio here is 5 over 4. 5 over 4 is certainly greater than 1, so we have divergence. Okay, so this series does not have a finite sum. We had one other one I wanted to look at. Let's say we had 1 plus x squared plus x cubed plus blah blah blah. And I wanted to know, when did this thing converge? Well, as long as the common ratio, we're multiplying by x each time. As long as the absolute value of x is less than 1, then we're okay. That means x has to live between -1 and 1. Okay, for divergence, that would mean that the absolute value of x needs to be greater than or equal to 1. I'll put the greater than or equal to 1 in just a second, which means x lives between -infinity and -1 with a closed bracket, and then bracket 1 to infinity, and we'll try to sneak in the infinity the best we can with that interval notation. Okay, so that is a little bit more convergence. So when we see you in Calculus 2 in a couple semesters, you'll have some idea what's going on.